right, IM2 classes. Today we're talking about solving right triangles. So we're going to be given some information. We're going to find all the missing parts. At least that's the goal. We're going to learn how to find angles. You're just given a couple of sides today, and then the next lesson we will be putting it all together with trig and Pythagorean theorem and the triangle sum theorem. So let's get into inverse trigonometry. So first thing we need to do is know how to actually work the calculator for inverse trigonometry. So we're going to be setting up equations that are going to look like something like this. We won't have a decimal here. There'll be fractions, but we're going to work with decimals right now. And we need to basically solve for A. All right. So we have sine of A is equal to 45. So when we're solving equations, we do the opposite. We do the inverse of the operation that's being done to what we're solving for. So what we're doing here is we are taking the sine of A. So we need to do the opposite of the sine of A, or the inverse of the sine of A. A lot of people think that'd be cosine. Some people guess tangent, but it's actually called inverse sine. So what we're going to do, put a little line of separation, even though this is only a one-step problem. I'm going to have sine of A is equal to, going to give some space here. I am going to take the inverse sine. It's just a sine to the -1 of 0.45. So what we want to do here, we use a calculator from here. Let me bring up a calculator so you can see what's going on with this. So with the calculator, maybe, there we go. So with this calculator, you can see the sine, cosine, tangent functions. We want to make sure it's in degree. Right? We talked about that last lesson. Make sure your calculator is in degree. To find the inverse on this one, it's an inverse button here. If you have a normal calculator like this, you're going to push the second button. All right. And then the sine, cosine, or tangent. So you're going to do inverse sine. There we go. So it comes up as arc sine here. It's the same thing. Arc sine, inverse sine are the same thing. 0.45, just like that. And you get 26.74. All right, so let's go back to the lesson. Where is it? All right, so what happens over here is this sine and inverse sine cancel out. You just have A, and then the inverse sine of 0.45 was 26. I already forget what it was. Second, 0.45 is equal to 26.74. We'll do one decimal place, 26.7. All right, let's do one more with those. We'll do cosine here. So first thing, or the only thing really you need to do to solve this is you're going to take the inverse cosine of both sides. So it's going to be the inverse cosine of A, and then the inverse cosine of 0.32. Inverse cosine of A cancel out. So I'm going to do the inverse cosine. So I push second on my calculator, and then cosine 0.32, and that comes out to 71.3. There we go. Same thing with tangent. We don't need to do a tangent. Let's go ahead and skip to a problem here. So we're finding angle A. So this one we do need to use SOHCAHTOA. So first thing I'm going to do is label the side lengths opposite adjacent hypotenuse. So this side length here is the hypotenuse, longest side. We're trying to find angle A, so I'm going to put my eyeball in angle A here. The eyeball is looking at the opposite side. And so this side next to it that's left over is the adjacent side. So you're going to ask yourself, kind of like what we did with normal trigonometry, what side length do you know what side length are you looking for? But this time you're just, what two side lengths do you know? That's what's going to give you what you're going to work with. Let me write my SOHCAHTOA the way I like to write it. SOHCAHTOA. So we have the adjacent, we know the adjacent, and we know the hypotenuse. So we are, or not the hypotenuse, the opposite. So which trig function uses adjacent opposite? That's going to be tangent with the opposite and adjacent there. So I'm going to put, no, let's leave it as A. So to find this, we're going to do tangent of A, side we're looking for, is equal to opposite 30 over adjacent 20. I'm giving myself some space there so I don't have to rewrite it, because to solve this, I'm going to do the inverse tangent of both sides. And from there, the tangent and inverse tangent cancel out. You get A is equal to, so inverse tangent of 30 divided by 20. Make sure if you're putting this into a calculator, you close off the parentheses. I don't know if you can see that. So make sure, yeah, that's backwards. Maybe, I don't know. Close off the parentheses when you're doing this, because it might give you some angles you don't like. But the inverse tangent of 30 over 20 is 56.3, and that's it. So that angle is 56.3 degrees. Yeah, let's do one more. So same thing, I'm going to label the sides opposite, adjacent, hypotenuse. This time we're not finding angle A, we're looking for angle C. So make sure you pay attention to what you're actually looking for. Mark that angle. Put your eyeball there, and the eyeball is looking at the opposite side. This side over here is the hypotenuse. It's the longest side. It's across from the right angle. And then this side left over is the adjacent. So again, we are going to use SOHCAHTOA. Ask yourself, what two side lengths are you working with? We have the adjacent and we have the hypotenuse. So which trig function uses adjacent and hypotenuse? That is going to be cosine, adjacent and hypotenuse. So it's going to be cosine of C is equal to the adjacent 14 over the hypotenuse 26. And then to solve this, you're going to do the inverse cosine of both sides. And so the cosine, inverse cosine, cosine cancel each other out. You're left with just C. So inverse cosine of 14 divided by 26 is 57.4. All right, I think that'll do it. Next time we're going to put all this together and find all the missing parts of right triangles. We will see you then.